This was a short one, but then there are quite a few things that we have discussed today. We did the simplest of the linear regressions. We did a regression against a binary variable, and we also did using a categorical variable to predict the variability of a continuous variable. There are some additional tests that you can do in checking the validity of your prediction model. So there is this, there are these assumptions that need to be started. For example, if you are using two continuous variables, you need to be sure that they have a linear correlation between the two of them. So we can go back. I'm just looking at our time. I see that we still have a few more minutes, so I can demonstrate. Chart builder, scatter plot. Yes. Okay, come to scatter plot. Want to plot a scatter plot of the mental health score, which is the dependent variable. The dependent variable comes onto the y-axis, and hours worked, which comes onto the x-axis. And then we just click on OK. We wait for SPSS to do its thing, and it's going to. Where's the chart? Okay, it's still running the graph. Okay, mental score versus hours worked. So you can see it doesn't have a linear relationship. So basically, what this is telling you is that regression model is very likely to be a poor predictor. So hours worked is a poor predictor of mental health score. Usually, for any regression model to be valid, you need the two at least one of the two continuous variables needs to be normally distributed, and then they need to have a linear relationship between the two of them, either a positive linear relationship or a negative linear relationship. And you also need for that's homoscedasticity, that's for every predicted value of someone raised their hands. Okay. Kayode, yes?
Sorry for cutting you short, but there's still a part that is really confusing. Now, when the p-value is less than 0.05, you say it is statistically significant. Now, this first model that we run, like this one for mental health score versus hours work, the p-value we got was less than 0.05.
It was statistically significant.
Okay.
But then
I think that means
it means that it's statistically significant. But then just highlighting to you some other things that you need to take into consideration before you can use that model and say that this is a robust model and this is something that you can actually use to predict the mental health score. So in terms of statistical significance, yes, it has given you that a good p-value, but that alone should not make you happy, because first place were the assumptions for linear regression satisfied by the variables that you are trying to compare. For example, if you are doing a t-test between a paired sample t-test, for example, and you decide to go ahead and enter SPSS use the software to generate your t-test. Before and after, it gave you the t-statistic, it gave you the p-value, and you are very happy. But then the continuous variable that you are testing is not normally distributed. So it means that your test is not valid. Even if you are having a good p-value, your test is not valid because the assumptions for that test have not been satisfied.
All right, I understand.
Kaide, are you now?
Yes, sir.
Okay. So there is this I just want to show demonstrate how you can check the residuals because there is, I'm sure you are told about the residuals. That is the difference between the predicted and the observed values of x for every value of y. So those residuals, are they normally distributed? That's also one of the assumptions that needs to be satisfied. So I think there's a way we can actually ask SPSS to plot that graph. Let's see. Spot plots. So I think this goes to the x and this goes to the y. Normal probability plot. So usually you are going to get you would get this in form of an oblong shape to show the correlation and if it is actually normally distributed. You can also plot a normal curve for this for the residuals. Let's check again. Histogram. Okay, so one of the assumptions is satisfied, which is that the residuals are normally distributed. But then if we go up here, this is the where is it here? This is the two variables. They don't have a linear relationship between the two of them. If we want to go further to check whether either the mental health score or the hours worked is normally distributed, we can also do that. Where is the mental health score? Bring it here to the horizontal axis, and then we click on OK. Okay, so this looks like it's normally distributed. So one of them is normally distributed, and the residuals are normally distributed, but then there's no linear relationship between the two of them. So These tests that we have demonstrated are just for the sake of demonstration purposes. Once you have done, before even doing your regression, you should check the assumptions between those variables and see if they satisfy those assumptions. So you'll be able to know whether or not a regression model from those variables is going to be valid. Some things that can be done if, for example, this mental health score is not was not normally distributed, depending on the kind of variable you are looking at. Sometimes we do transformations on the variable, like we can decide to square it and see if it's going to give us a normal distribution. We can take the square root, we can take the logarithm and all that, but I guess that might be discussed in class subsequently, and then when in a subsequent practical session, we can also do that. One thing I would like to emphasize is that as someone using these statistical software, whether it's SPSS or R or any other statistical software, it's important to always have a reference material that you're going to refer to. For example, the lectures that you have done, the lecture notes from these sessions can be a reference material. If you've forgotten how to do something that you need to do, you know that that particular method or test exists, and that's and you know where to apply it. So maybe it's just you find yourself using a more recent version of SPSS and you don't know where they have gone to hide a particular function. You can just go on YouTube and ask how to do this on SPSS version 27, 28, 29, and it's going to show you how that is done. And if you use Google and YouTube judiciously, it's hard to get lost. So if there are no other questions, I would like to end the session here and wish us all happy holidays. So do we have any questions?
Very much, sir. Thank you, sir.
All right. Bye, everyone. Happy Leia, and come with some meat for us in the next lecture.
Thank you very much, sir.
No problem.